Hi class, good morning. I am Christine Angel de Camo. In this video, we're going to learn about product tagging, modular arithmetic, universal product code, international standard book number, and lastly, quick response code. So first, what is product tags? Product tags are used for the easy identification of products as well as used for tracking and inventory purposes. Or scanned into a computer or transmitted in some other fashion, there's a chance that one or more digits in the number will change or rearrange as they move from one location to another. Here are the most common types of transmissions errors with examples and relative frequency of occurrence. Any of these errors may occur during transmission. The receiver can, of course, try contacting the sender to check, but this may not always be possible. This scenario gives rise to the development of methods by which the receiver can recognize when a product tag has been transmitted correctly. Some of these methods fall under the category called check-digit schemes. One example is a system using error-correcting codes, which are able to identify errors and then correct them automatically. Most check-digit schemes append an extra digit or digits to the product tag and then use the digits to check for transmission errors. If an error is detected, the item is then rechecked until the correct tag is read. To investigate the error detection capabilities of different product tagging schemes, the underlying computations will be examined. So, let's getting forward to another topic, which is modular arithmetic. Given integers e and b and the positive integers n, a and b are considered congruence modulo n if n divides e minus b. The relationship is expressed symbolically as e is congruence to b modulo n. For example, 30 is congruence to 6 modulo 12 because 30 congruence to 6 is divisible by 12. Equivalent ways of stating the relationship of congruence includes: first, it leaves a remainder of b when divided by n. For example, 30 congruence to 6 modulo 12, where 30 is divided by 12 has a remainder of 6. E is equals to tn plus b for some integers of t. For example, 30 is congruence to 6 modulo 12 because 30 is equals to 2 times 12 plus 6. When arithmetic modulo of n is done, multiples of n are discarded. For example, 14 plus 23 is equals to 37 and equals to 7 times 5 plus 2 is congruence to 2 modulo 5. Similarly, 16 plus 29 is equals to 464 equals to 154 times 3 plus 2 is congruence to 2 modulo 3. It is also possible to discard multiple of n before performing the arithmetic operation. Thus, 14 plus 23 is congruence to 4 plus 3 is equals to 7 is congruence to 2 modulo 5. And 16 times 29 is congruence to 1 times 2 is congruence to 2 modulo 3. When it comes to equations, solve 3x plus 1 is congruence to 2 modulo 7. Ask which integer or integers satisfies or satisfy the congruence. Take note that 3x plus 1 is congruence to 2 modulo 7, which is equivalent to 3x minus 1 congruence to 0 modulo 7. Likewise, x is equals to 5 is a solution since 3 times 5 minus 1 is equals to 14, which is congruence to 0 modulo 7. However, notice that 12 also works since 3 times 12 minus 1 is equals to 35, which is congruence to 0 modulo 7. In fact, once the solution x is equals to 5 is found, more can be seen by adding or subtracting multiples of 7 to the solution to get 5 and 5 positive and negative 7 and 5, positive and negative 14 and 5, positive and negative 21 and 5, positive and negative 28, and so on. When solving congruence modulo n, only one solution is needed, as adding or subtracting multiples of n shows other solutions. Furthermore, this restricts the research or the search in the mode 7 case among the numbers 0, 1, 2, 3, 4, 5, and 6. It means nga ang modulo 7 has only 7 values which is lesser than the number 7. So, kung mag-count, magsugod siya sa number 0 which is our starting point sa count. Kantahay, 0. At mo nito number 1. 1, 2, 3, 4, 5, 6, 7. Yang atong ika-7 nga values is mao ang 6 which is lesser than the number 7. Example number 1. Solve 4x plus 1 that is congruent to 2 modulo 9, which is equivalently 4x minus 1 congruent to 0 modulo 9. So, by trying that our x is equal to 0, 1, 2, 3, 4, 5, 6, 7, and 8. It can be seen that x equals to 7 is a solution. So, first we need to compute it if the statement is true. So, first substitute the x into 7. 4 times 7 plus 1 is congruent to 2 modulo 9. 4 times 7 is equals to 28 plus 1. That is congruent to 2 modulo 9. 28 plus 1 is equals to 29 congruent to 2 modulo 9. Other is 4 times 7 minus 1 is congruent to 0 modulo 9. 28 minus 1 is congruent to 0 modulo 9. 28 minus 1 is equals to 27 congruent to 0 modulo 9. Example number 2. Solve 2x is congruent to 1 modulo 4. Solution. Equivalently, this is 2x minus 1 congruent to 0 modulo 4. Trying x is equals to 0, 1, 2, and 3 shows that 2x minus 1 is equals to negative 1, 1, 3, and 5, none of which are multiples of 4. Hence, 2x is congruent to 1 modulo 4 has no solution. Does the following look familiar to you? This is Universal Product Code or UPC. Nearly every item that you purchase in a grocery store or department store has a UPC on it somewhere. These barcodes were originally created to help grocery stores speed up the checkout process and keep better track of inventory. The system quickly spread to many other retail products. Manufacturers applies to the Uniform Code Council (UCC) for permission to join the UPC system and pays an annual fee. The UCC then issues a manufacturer's identification number and provides guidelines on how to use it. The manufacturer designates a UPC coordinator who is responsible for assigning item numbers to products, making sure the same code is not used on more than one product, retiring codes as products are removed from the product line, and other related tasks. In the 12-digit of UPC, the first digit identifies the type of product. The following table lists the different values of X and when each is used. In the barcode above, 6 is the type of product. 39382 is the manufacturer's identification number, and 00039 is the item number. In general, every item the manufacturer sells, including every size of the packaging and every repackaging of the item, needs a different item code. For example, a 12-ounce can of soda needs a different item number than a 12-ounce bottle version, as does a 6-pack of 12-ounce cans, a 12-pack, a 24 can case, and so on. It is the job of the UPC coordinator to keep track of all these numbers. The last digit exceeds 12 of the UPC is called a check digit. This digit lets the system determine if that number has been scanned correctly or not, given the 11-digit string x sub 1, x sub 2, 2x sub 11, and the check digit, which is x sub 12, is appended such that the whole 12-digit code word satisfy this equation. The UPC 053600-10054-0 is valid because the following calculation results in a true statement where 40 is congruent to 0 modulo 10. So, ang imong buhaton is i-calculate ni siya through this equation para may bawaan kung correct ba ang statement. So, sunod ni imong buhaton is mag-substitute ka, which is i-substitute nimo tanang value nga x. Like, ang x sub 1 is 0. Arita magkuha sa mga x values. So, then after sa pag-substitute ng ani, imo ni siyang i-times, then add. So, i-bring down nimo siya. 0, bring down 5, bring down 3 times 4 is 12, and bring down 0, which is congruent to 0 modulo 10. So, ang sunod yung button is add all the value. So, 0 plus 9 plus 6 plus 0 plus 0 plus 3 plus 0 plus 0 plus 5 plus 12 plus 10 is equals to 40, which is congruent to 0 modulo 10. To know kung tinuod ba jud or true statement ang 40 is congruent to 0 modulo 10, we are going to use number line. So as we know, ang modulo 10 have also 10 values, which is magsugod pud siya sa 0 ang count. So let's start counting. We are going to start here as our first value. 1, 2, 3, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. So, ito nakuan nga ang value sa 0 is 1. While ang value sa 40 is also 1, maong sila kay congruence. Yang statement sa illustration 1 is a true statement. Second illustration, the UPC 3-70501-09110-4 is invalid because the calculation below results in a false statement, which is 39 is a congruence to 0 modulo 10 is a false statement. So, to know if the illustration number 2 is a false statement, we are going to use a number line para atong makita jud og nganong false statement siya. No, modulo 10 has 10 values. Is kung mag-count siya, magsugod jud siya sa 0. So, let's count. As we know, modulo 10 kay na jud siya values nga 10 rapod, which is magsugod siya count sa 0. So, mao na is first value na to. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then, balik na po sa 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. So, as we know, nga ang value sa 0 kay 1. Ni ang kaning 39 is 10. So, ila siya nga dili sila congruent to each other. That's why ang illustration number 2 is a false statement. Example, consider the product identification number is 5-02003-91562. Generate the check digit. Solution. Let C be the check digit that will be appended to the product identification number to create the UPC 5-02003-91562-C. To find C, the following equation is solved. So, buhaton ra is i-substitute 3 times 5 plus 0 plus 3 times 2 plus 0 plus 3 times 0 plus 3 plus 3 times 9 plus 1 plus 3 times 5 plus 6 plus 3 times 2 plus C is congruent to 0 modulo 10. 3 times 5 is 15 plus 0. 3 times 2 is 6 plus 0. 3 times 0 is 0 plus 3 plus 3 times 9 is 27 plus 1 plus 15 plus 6 plus 6 plus C is congruent to 0 modulo. So, add all the number. It is 79 plus C congruent to 0 modulo 10. The only digit C that solves this equation is C is equals to 1, which is 79 plus 1 equals to 80, which is congruent to 0 modulo 10. Hence, the UPC is 5-02003-91562-1. UPC catches all single-digit errors but not all transposition of adjacent digits errors. Next topic is all about International Standard Book Number. The International Standard Book Number, ISBN, code is used throughout the world by publishers to identify properties of book. The first 9 digits of the ISBN represent information about the book, including its language, publisher, and title. To guard against errors, the 9-digit string is encoded as a 10-digit code word, X sub 1, X sub 2, 2X sub 10. The appended 10th digit is a check digit, chosen so that the whole 10 digits code word satisfies X sub 1 plus 2X sub 2 plus and so on is congruent to 0 modulo 11. That is, the weighted sum is evenly divisible by 11 if 10 X sub 10 rather should be equal to 10 and X is used. The ISBN code can detect any single and double error created by the transposition of 2 digits. In the ISBN 0-8218-2626-X, the 0 indicates that the book was published in either the United States, United Kingdom, Australia, New Zealand, or Canada. The second string, 8218, identifies the publishing company. It is the code for the American Mathematical Society. The third string, 2626, is the number that is given to each book the corresponding company publishes. The book should be the 2626th book that was published by the AMS since the introduction of the ISBN. The last part, X, is the check digit. It is the same as the number 10. The ISBN 0-13-088976-8 is valid because the following calculation results in a true statement where 352 is congruent to 0 modulo 11. So first, ngayon mong buhaton is substitute ang tanang X values. So the outcome is 1 times 0 equals 0, 2 times 1 is 2, 3 times 3 is 9, 4 times 0 is 0, 5 times 8 is 40, 6 times 8 is 48, 7 times 9 is 63, 8 times 7 is 56, 9 times 6 is 54, 10 times 8 is 80, then add all the outcome numbers. 352 is congruent to 0 modulo 11. Example, Consider the ISBN is 0-387-94225-C. Find the value of the check digit C. Solution: to find C, the following equation is solved. So, ang imong kinahanglan jud is substitute the numbers. After that is multiply. Next is add all the outcome numbers. So, ang answer is 202 plus 10C is congruent to 0 modulo 11. The only digit C that solves this equation is C is equals to 4. 202 plus 10 times 4 is equals to 202 times plus 40 is equals to 242, congruent to 0 modulo 11. Hence, the complete ISBN is 0-387-94225-4. Since January 1, 2007, ISBNs have contained 13 digits. The ISBN 13 check digit must range from 0 to 9 and must be such that the sum of all the 13 digits, each multiplied by its integer or weight, alternating between 1 and 3, is a multiple of 10, that is x sub 1 plus 3, x sub 2 plus x sub 3 plus 3x sub 4, and so on, which is congruent to 0 modulo 10. The ISBN 13 check digit C of 978-0-306-40615-C is calculated as follows. So, substitute all the x values. So, 1 times 9 is equals to 9. 3 times 7 is 21. 1 times 8 is 8. 3 times 0 is 0. 1 times 3 is 3. 3 times 0 is 0. 1 times 6 is 6. 3 times 4 is 12. 1 times 0 is 0. 3 times 6 is 18. 1 times 1 is 1. 3 times 5 is 15. Plus C is congruent to 0 modulo 10. Then add all the outcome values. So, it's equal 93 plus C congruent to 0 modulo 10. The only digit C that solves this equation is C is equals to 7. So, substitute the C into 7. 93 plus 7 is equals to 100, where 100 is congruent to 0 modulo 10. So, we are here in our last topic, which is quick response code. So, what is quick response code? Quick response code, or QR code, was invented in Japan by Toyota's subsidiary Denso Wave in 1994 to track vehicles during the manufacturing process. This is designed to allow high-speed component scanning. Smartphone users can install an application which first scans a displayed code, second converts the code to a URL, and third opens the smartphone's browser to the website of the company, store, or product associated with the code. Because of this error correction capability, it is possible to create artistic QR codes that incorporate colors, logos, and other features, making them more readable or attractive to the human eye, but still can scan correctly. Thank you for watching. I hope you learned a lot about the topic that I have discussed a minute ago. Thank you.